Now let's take a look at Official Guide 2016 DS number 15. So, I'm going to write the prices of the house like this. And the question is asking, what is the price of the second largest asking price? So there are three variables, obviously, which are A, B, and C. And in order to match the number of variables to the equation, we need three equations. So the condition 1 has one equation, and the condition 2 has another equation. And we lack one equation, so there's high chance that E is going to be our answer choice. So I'm going to use both the condition 1 and 2 at the same time. And the condition 1 states C minus A equals $130,000. And the condition 2 states C minus B equals $85,000. So using both of the equations, we cannot obtain unique value of B. So the conditions become not sufficient and the correct answer choice is E. Please remember that answer has to be unique. Now let's look at Official Guide 2016 DS number 16. So from the original condition, we can get two variables which are R and W. So we need two equations in order to match the number of variables to the number of equations. And the condition 1 has one equation and condition 2 has another equation. So there's high chance that C is going to be our answer choice. So I'm going to use both the condition 1 and 2. And using both conditions, we have R equals 0 and W equals 7. And the answer becomes yes. However, when R is 1 and W is 7, the answer becomes no. So the conditions become not sufficient and the correct answer choice becomes E. Now let's take a look at Official Guide 2016 DS number 18. According to the variable approach method, we have two variables which are x and y, and we need two equations in order to match the number of variables to the number of equations. And the condition 1 has one equation and the condition 2 has another equation. So logically, there's high chance that C is our answer choice. So I'm going to use both the condition 1 and 2. The condition 1 has xy equals 1 and x equals 1 over y, and the answer becomes yes, and the condition is sufficient. And the condition 2 has 1 over xy equals 1. So x equals 1 over y, and the answer is yes, and the condition is sufficient again. So because the condition 1 and 2 are the same, the correct answer choice is D. Now let's take a look at Official Guide 2016 DS number 19. This is a 2x2 question that frequently appears in the GMAT math, so please make note on this type of question. And what I'm going to do now is I'm going to put information from the question into a 2x2 table. So I'm going to draw a table like this. And another line like this. And for the first column, I'm going to put those who own a fax machine. And the second column is for those who do not own a fax machine. And the first row would be for those who own laser printer. And the second row would be for those who do not. And I'm going to designate each box as A, B, C, D. And the question is, basically, what is D? So there are four variables which are A, B, C, D. And in order to match the number of variables to the number of equations, we need 4 equations. The condition 1 has 1 equation, and the condition 2 has 1 equation. So there is high chance that E is going to be our answer choice because we lack 2 equations. So I'm going to use both the condition 1 and 2. The condition 1 states A plus B plus C is less than 50. And the condition 2 gives us that A equals 15. So we cannot obtain a unique answer for D. Not unique. So the conditions become not sufficient, and the correct answer choice becomes E. Now let's take a look at Official Guide 2016 DS number 20. According to the variable approach method, there is one variable, which is W, and we need 1 equation in order to match the number of variables to the number of equations. And the condition 1 has 1 equation, and the condition 2 has another equation. So logically, there's high chance that D is going to be our answer choice. So I'm going to look at the condition 1 and 2 separately. In case of condition 1, W to the power of negative 2 becomes W to the power of negative 1 to the power of 2. So this is 1 over 2 squared. So this becomes 1 over 4. And the answer is unique and the condition is sufficient. In case of condition 2, W to the power of negative 2 becomes W to the power of 8 to the power of negative 1 over 4. So this becomes 8 to the power of negative 1 over 4. And the answer is unique and the condition becomes sufficient. And the correct answer choice is D. Now let's take a look at Official Guide 2016 DS number 21. And I'm going to modify the original condition and the question using variable approach method. And first I'm going to designate investment for the first year as V. Then the question becomes, by modifying the original condition and the question, becomes V times 1.04 to the power of 3 minus V equals the value. So there's only one variable, which is V, and in order to match the number of variables to the equation, we need 1 equation. So the condition 1 has 1 equation, and the condition 2 has another equation. So logically, there's high chance that D is our answer choice. So I'm going to look at condition 1 and 2 separately. The condition 1 has V times 1.04 equals 4,160. So V becomes 4,160 over 1.04. And V becomes $4,000, and this is unique. And the condition becomes sufficient. And the condition 2 states V times 1.04 to the power of 2 equals $4,326.4. And V becomes $4,000 again. And the condition is sufficient because the answer is unique. So the correct answer choice is D.
Let's take a look at question number 22 of the DS section in the 2015 official guide for GMAT. Here we're given a speed to question, so we represent that using VT equals 50, the total distance. And we have two variables here, V and T. To solve for them, we first need two equations, but we're given one equation here already. So really, just one more equation is needed to solve for the two variables. In condition 1, we're given one equation. Condition 2 gives us another equation. So chances are high that D will become our correct answer. Let's verify that. Looking at condition 1 in detail, it's telling us that 60t1 is equal to 30 because that's the first half of the trip. Solving for t1, we have 30 over 60, which reduces down to a half, and half of an hour is 30 minutes. During the second half of our trip, she spent 20 miles for 50 miles per hour, so that's 50t2 equals to 20. T2 is 20 over 50, reducing down to 2 over 5. That times 60 minutes is 24 minutes. What about the total time? We simply add up T1 and T2, which is 30 minutes plus 24 minutes, for a total of 54 minutes spent for a 50-mile ride. Then what's her speed? Quite simply put, it would be the total distance over time, so that's 50 over 54. There you have it, we have our answer. Condition 1 is indeed sufficient to solve the problem. Condition 2 is the same. As in condition 1, total time happens to be 54 minutes, so the answer will be the same, and 2 is also sufficient. So finally, D is our answer. This sort of problem solving is called the variable approach method, and nowadays it's the most proven and effective way of getting a correct answer in the DS section of the GMAT math.